Hi, everybody. How's it going? Good. Our plan for today, we're going to wrap up chapter 14. We have one last topic to talk about. And that'll be it. So next class we'll do the review assignment, make our note card, and be testing the Monday next week. Krista.
Was there a homework quiz last week?
Yeah, last class we did the homework quiz.
Okay. Do you think I could take that?
CT next week? Yes.
Yeah. That's better. Okay. Thank you.
You're welcome. Everybody okay otherwise? Any other questions before we dive in here? Alright. So in section 14.3, we're going to be talking about solving inequalities. What's the difference between solving an inequality and solving an equation? Okay, there's no equal sign. So what's that mean in terms of like kind of answer you're going to get? Okay, how many of those numbers are there going to be typically? Infinitely many, right? So rather than expressing our answer as like x equals 2 or x equals 5 or something like that, so we're going to express our answers as an interval to describe the intervals that satisfy the inequality, rather than just like single values. Everybody okay with that plan? So to correctly do this, to find these intervals, what we're going to do is we're going to be building something called a sign diagram, S-I-G-N, like a stop sign or a plus minus sign. That's really the kind of sign we're talking about, is a sign diagram. So to build a sign diagram, we're going to need to find where the equation is equal to 0 and where the equation becomes undefined. So those are the two things we need to start. So for our first example, we have x squared minus 4 is greater than 0. Okay. So what kind of a function is x squared minus 4? Quadratic. Okay, more generally even than quadratic, though we could say it's a polynomial, right? What can we say about the domain of all polynomials? The domain of any polynomial is all real numbers. So is there any place where that polynomial is going to be undefined?
No.
No, right? Handle that spot right away just by recognizing that we have a polynomial there. What kind of things can give you undefined? Rational functions, and there's one other type. Something with a radical in it. So kind of on the right track, right? Everybody's okay? So unless you see one of those, the undefined piece doesn't really matter to you. So far, so good? All right. So now let's move on to the solving piece. X squared minus 4 equal to 0. How does it solve?
Difference of 2 squares.
Okay. So x plus 2x minus 2. So my solutions are -2 and +2. Everybody feel good to hear? So now I'm going to start drawing my sign diagram. Let's grab a new color. So my sign diagram is going to be a number line. And the numbers that I care about on my number line are going to be the solutions equal to 0 and the places where it's undefined. So for this one, we just have -2 and +2. Everybody's okay with where I got the numbers that I'm going to put on my number line? Important point, the order the numbers go on the number line has to go from small to big, right? They have to be in the same order that they would appear on the number line. Everybody's okay with that? I know you're like, no dumb, Mr. Kulik, but I promise you, like, somebody screws this up every year. Just gotta say it. What I'm gonna do now is I'm gonna observe that my number line's been divided into 1, 2, 3 different sections. Everybody agree with that? So the stuff less than -2, the stuff between -2 and 2, and the stuff bigger than 2. What I'm going to do is I'm going to pick a test value from each of those 3 sections. The value I pick doesn't really matter, but it needs to come from one of those sections. So less than -2, I'm going to pick -3. Between -2 and 2, I'm going to pick 1 or 0. Bigger than 2, I'm going to pick 3. Is everybody okay with the test values? Could you have chosen different numbers? Sure. Instead of -3, I could have picked -13/2. But why would you want to pick something convenient, right? It's your choice. What you couldn't do is instead of -3, you could not pick -1. Why not? Because -1 is more than -2. It's coming from the wrong part of the sign diagram. Everybody's okay? All right. Now what I'm going to do is I'm going to figure out what, if this is like f of x, I want to figure out what f of -3 is, what f of 0 is, and then what f of 3 is. Everybody's okay with that plan? But I don't really care what the number is. I just care whether it's positive or negative. So I'm going to think about plugging in to the factored form. And I'm just going to look at whether I have multiplied by positives or negatives and just keep it simple. Could you plug the number in and get an actual number out? Sure. It's just a little bit more work than I'm interested in doing right now. It's not wrong to do that. Everybody's good? All right. So if I take -3, my test value, and plug it into x plus 2, do I get a positive or negative? Negative. -3 plus 2 is -1, right? If I plug it into x minus 2, I get negative times negative is positive. Everybody's good? Now I'm going to do 0. I plug 0 into x plus 2, I get positive. If I plug it into x minus 2, I get
Negative.
positive times negative is negative. And then if I plug 3 in, I get, and then I get,
Negative.
and positive times positive is positive. Is everybody okay with what I did here? Again, you could plug those in and get the actual number. That's fine. I'm just not interested in doing it right now. It's so easy to do without a calculator. I'm just going to use my noggin. If you're not comfortable using your noggin to do that, by all means, plug in, get an actual number to come out. That's fine. Does it matter if you plug in here or here? Nope. Should get the same number either way. Whatever is more convenient for you. So far, so good. All right. So we know that from everything less than -2 has to be positive. Everything between -2 and 2 is negative. Everything bigger than 2 is positive. That's what the sign diagram is telling us. Did you guys see that? What we still need to do is decide what's happening at 2 and -2. Okay? And then which one of these sections do I want? Do I want the positive parts or do I want the negative parts? So 2 little things left to do. The part that's going to tell me what to do for both of them is this. because it's not an or equal to. If I plug -2 into this, is 0 greater than 0?
No.
No, right? So I'm going to use a open circle. If I plug +2 into this, is 0 greater than 0? No. So I'm going to have an open circle there. Everybody's okay? Now, my inequality is something greater than 0. Right? So do I want the positive parts or do I want the negative parts?
Positive.
The positive parts, because greater than 0 means positive. Is everybody still good? Now what I'm going to do is I'm going to translate this sign diagram into intervals. So this first piece of my sign diagram starts at -infinity, and it ends at -2. Now the infinities always get a parenthesis. Does -2 get a parenthesis or a bracket?
Parentheses.
Parenthesis. Why?
Because it's equal to.
Because it's open, right? Yes. And then we'll do union. And then my next interval starts at 2, and it ends at +infinity. The 2 gets a bracket or parenthesis? Parenthesis, why? We have an open circle, or because it's a strict inequality. The infinity always gets a parenthesis, and we're done. That's my answer. Is everybody okay? We're going to do a couple more examples. I don't know, 4 more examples, something like that. I don't know. Everybody's okay? Kind of all roll the same way, though, just to give you like, oh, what if this happens? What if this happens? What if this happens? The process is going to stay the same, and just like, oh, something weird happened here. Oh, it's a little bit different, just to cover some of the contingencies. Everybody's okay? But still going to do the same thing. We're going to start by taking the thing, set it equal to 0 and undefined, find the values where that happens, build the sign diagram, figure out where it's positive and negative, turn that into an interval. All right. So again, I start by taking my inequality, writing an equation where it's equal to 0 and an equation where it's equal to undefined. I like to start on the undefined part first because it's the part that students tend to forget. So I like to do it first to try to remind you to forget that part. What type of an equation or what type of function are we have equaling to undefined? Cubic trinomial, or more generally, it's just a polynomial. Can polynomials ever be undefined? Nope. Oh, we're done. Is it always going to be none? No, we're going to get to examples where that isn't, but I'm going to do a couple easy ones first. All right. How do I solve this guy then?
You factor on x and you do short factor.
Great. So we'll start by taking out a greatest common factor of x. That's always our first step for trying to solve any polynomial that's equal to 0. And now Mark notices that this remaining piece should factor. What multiplies to give us 4 and adds to give us -4?
X minus 2, x minus 2.
Okay. So what are the solutions that I'm going to get out of this?
X equals 2, 1 plus 2 is 2.
You missed one.
X equals 0.
X equals 0. X equals 2. And then x equals 2 again. Is everybody okay with where I got the 3 solutions from? Okay. Again, it's easy to forget about this guy out front. Don't forget him. All the factors get set equal to 0. All right. Now let's build our sign diagram. What numbers are going to go on my sign diagram?
2 and 0.
Okay, what order do they need to go in?
0 on the left. 0 on the right.
Okay, 0 first and +2 afterwards. Why? Because 0 comes before 2 on the number line. Just counting, right? All right. Then we pick some test values. So the stuff left of 0, what x value should I pick here as a test? -1 sounds great. How about between 0 and 2? 1 sounds great. And then to the right of 2?
3.
That sounds wonderful. I love all of those. Yes. Okay. Where am I going to think about plugging these into, though? I'm going to think about using the factored one, because it's going to make the, is it positive or negative, just easier to deal with, right? When I plug -1 for x, I get, and then when I plug in here, and I plug in here, product of 3 negatives is a negative. Okay? If I plug 1 in here, I get here, here, overall. Good. If I plug 3 in here, I get, and then here, and then here, overall. Okay. Now, I hear several of us mumbling out the answers. Is everyone else that's not mumbling okay with what we're doing? It's clear? Okay. Should be relatively easy to handle, but like, you just need to check, right? All right. Now that we've built out our sign diagram, we have to look at 0 and 2 to see if those are open or closed, right? If I plug 0 in for x, I get 0 less than or equal to 0.
That's true.
That's true. So I need a
Oh,
closed circle. If I plug 2 in for x, I'm going to get 0 is less than or equal to 0. That's true also. Okay. And then I'm interested in less than or equal to 0, right?
Single.
What parts of my sign diagram am I interested in?
The negative.
The negative part. And
We're at 0.
we're at 0, which is at specifically,
0 and 2.
well, 0 is kind of already included in that part, but this guy also, right? Is everybody okay? Good. All right. Let's rewrite this as an interval now. This first piece starts at negative infinity. Good. Everybody's okay there? Why was it a bracket on the 0?
Because it's equal to.
Because it's an equal to or a filled circle. Very good. And how do I write just the 2?
0, 2.
No, 0, 2 would be all this stuff, where it's positive. Not 2 with a bracket on both sides, because that's the notation for an interval. What we want is the notation for just like a single set. So we just use the curly bracket for single values. An interval is a parenthesis or bracket, and it's everything in between 2 values. Can't have everything in between like 2 of the same thing, right? We have just a singleton value or a couple singleton values that are not an interval. Use the squiggly set brackets and then you list them separately. Certainly.
Thank you.
You guys feel okay? All right. Ready to move to the next one? Okay. All right. How do we start?
Factor.
Oh, sure, we can factor. How does the top factor?
X minus 4, x plus 1.
Yeah. You got it. Just shout it out. Don't have to wait for Mark to do it. And the bottom?
x minus 2x minus 1.
Good. Note that nothing can reduce, right? Important point there. Okay. So, just like before, we're going to take our function, set it equal to 0, and also set it equal to undefined. Okay. What type of function are we looking at here? Rational. Notice this is a fraction. It has the x's in the denominator, so it's a rational function. When is a rational function undefined? When the denominator is 0. Everybody's okay there? When is a rational function equal to 0? When the numerator is equal to 0. Everybody so far so good? All right, let's draw our number line. What numbers are going to go on our number line?
X equals 4x minus 1.
I'm going to need -1, +1, +2, +4. All of the values where the function is either equal to 0 or undefined. And then I need to make sure I write them in order of how they would appear on my number line. How many test values am I going to need here? 5. What should I pick here to the left of -1?
-2.
That sounds good. Between -1 and 1?
Negative or 0.
I like 0. That would be fine. -1/2 would be okay. Between 1 and 2?
1.5.
Okay, I'm just going to write 1.5. Is everybody okay with that? Between 2 and 4? 3. And bigger than 4? Okay. Everybody good with the test values? Okay. And again, do the actual values here matter what we choose? No, not as long as they land in that inside of that interval we're talking about, right? Could have I done, like 1.1 instead of 1.5? Sure. Could I have done like, 2.6 instead of 3? Yeah. Oh my goodness. All right. Let's plug these in. I'm going to plug them into the factored form. So I have 4 places. And we're just going to look at positive or negative still. Everybody good? So we're taking -2.
Negative.
Nope.
No, 0.
Negative. -2 minus 2 is -4. And then negative. So 4 negatives is positive. If I plug the 0 in,
Negative.
3 negatives is
Negative.
negative. You guys still feeling okay? 1.5. Yeah, so 2 negatives is positive. Plugging in 3. 1 negative is, and then plugging in the 5. I was worried. I'm glad you made that. Didn't really think it was that funny, but I'm flattered that you're still laughing about it. Is everybody good with how I've assigned the signs here? Right? That was same as always, right? A little more place to plug in, but Not a big deal. Now we need to decide whether things are opened or closed, right? If I plug 4 in, I'm going to get 0. Is 0 greater than or equal to 0? Yes, so the 4 should be closed. If I plug -1 in, I'm going to get 0 is greater than or equal to 0. So what do I put at -1?
Closed.
Closed. Now if I plug in 2, I get undefined. Is undefined greater than or equal to 0?
No.
No. So what do I put at 2 then?
Open.
Open. If I plug in 1, I get undefined. Is undefined greater than or equal to 0?
No. Open.
So we get another open. You're on it today, Krista. Is everybody comfortable as to why things are open and closed? The undefined parts are always going to be open, right?
Is actually rational, so you take that like is when the raising those zero so you take the minor
Everybody okay? The takeaway here are when we find the zeros, whether they're open or closed depends on the inequality symbol. Where we find where it's undefined, the discontinuities, those are always open no matter what. That's the takeaway. Lugo?
How did you get like the two equations? Like on how the left side's equal to 0 and the right side's equal to undefined?
So this is a fraction, right?
Yeah.
When is a fraction equal to 0? When it's like 0 over 2, right? When the top is 0 and the bottom isn't.
Yeah.
So I took the top and set it equal to 0,
Okay.
right? When is a fraction undefined? When I divide by 0. So I took the bottom and set it equal to 0.
So you just make those separately?
Yep.
Yep. Okay.
Because of what it's being asked to find. When is this fraction equal to 0? Top is 0. When is this fraction undefined? Bottom 0. That's it. Good. All right. Now, what parts of my sign diagram am I interested in? The positive parts and the negative parts?
Positive.
Positive. Why, Ian?
Because it's when it's greater than or equals.
It's a greater than or equal to symbol. So we're interested in here, here, and here. Everybody agree? So I'm going to have 3 intervals. The first one starts at,
Negative infinity.
and it ends at. And what are the symbols at the ends here?
Parentheses on the negative infinity and brackets on the -1.
Perfect. Everybody agree? Okay, what's the next interval start at?
1.
And it ends at? Great. And the symbols at the end are?
Parentheses.
For both. So far, so good. The next interval starts at? Ends at? Symbols at the ends are?
Brackets on the 4. Parentheses.
Parentheses around the yes.
Everybody feel good with what we did here? Okay. We're good as to why things are open and closed. That's typically the trickiest piece for something like that. Okay. I think I have one more example and we're done those for today. Sound good?
Yes.
All right. Okay. What do we got here?
Irrational function.
Well, I wouldn't say it's irrational, and it's not rational because it's got a square root. It's not a polynomial. This is like a composite function because it's like the composition of 2 things. Yuck. Let's start by just factoring the numerator though, because I see that's factorable. Everybody agree? What multiplies to give me negative 12 and adds to give me positive 1? 4 and negative 3. Wonderful. Okay. So just like before, we take our function set equals 0 and undefined. Those are going to give us the values for my sign diagram. Okay. This is still a fraction, right? When is a fraction equal to 0? When the numerator is 0. Pretty good there.
Yep.
Okay. So if I look at the undefined part, there's actually two things that can cause this to be undefined. One is that we have a fraction. When is a fraction undefined?
When denominator is
When the denominator is 0. But we also have a radical. What makes a radical undefined? Not when it's in the denominator. When the stuff underneath it is negative, right? Is everybody okay? So there's two things that are going to make this undefined. 0 denominator, and then the square root of a negative. Everybody's good? Okay. So if I take this, I can. What's going to cancel out the square root? Squaring both sides. So I subtract 1 and divide by negative, and I get x equals 2. Everybody good? Subtract the 2 over, divide by negative 1, and boop, 2. All right, what are we going to have over here now? And then what do I do?
X is less than negative 2. Oh no, when you flip the sign, as
Flip the sign. When do I flip it?
divide by negative.
When I divide by the negative. Is everybody okay there? All right. Now I'm going to draw my sign diagram. Everybody's okay. Now I'm going to do this a little out of order on this one because I got this inequality as part of my undefined piece. Right? This is saying that I'm undefined everywhere that's greater than 2. So what that says is that I don't need any of the number line that's greater than 2. I don't have to check anything over there. So that 0 of 3 doesn't matter. Because it can't actually get it. Because it's going to make the denominator undefined. Is that okay?
So you don't have to like test it?
I don't have to test anything over there bigger than 2. Exactly right. Now 2 is on the undefined side, so that's going to get an open circle. And because we are a strict less than, the negative 4 is also going to get an open circle. Is everybody okay with how I filled in the opens?
But isn't negative 4 less than?
Well, if I plug negative 4 into this, I'm going to get 0 is less than 0, which is not true. So remember, we're always plugging back into the beginning, right?
Yeah.
So far, so good? All right. How many test values am I going to need? It's just 2. Let's pick negative 5 and 0. Sound good? Right? I'll go back to say here, if I plug -5 into here, into here, and what has to come out of a square root?
A positive.
Always has to be a positive, right? So I don't even need to worry about the bottom. Got negative times negative.
Positive.
Positive. If I plug the 0 in, and then always positive, right? So the whole thing is negative. All right, what part do I need that's less than 0 then? Just the negative part here. So my interval I would write is that guy. You feel okay?
Yeah.
So your assignment from this section is 36 to 56 evens. So for Sunday, we have the worksheet 2. Remember, I passed this out to you guys, I don't know, sometime last week. Hasn't been due yet. If you need another one, they're right there if you need another. And then we had like 25 to 32 or something, or that sounds about right. Those are the solving problems. And then we'll have as a that's set 2, and then set 3 is going to be 36 to 56 even, and then the review, which we haven't assigned yet. Is everybody okay? So there'll be 2 sets due on Sunday. Good news is, about 30 minutes here to get cracking on some stuff, knock out some homework to not have to worry about it this week, which I know is a busy week of fun activities that you don't want to be doing math homework afterwards. So let's get some done in class.
May I go to that?
Yes.
No. Okay, how much story will you undivided?
This went out as though today.
What's your
Was
problem?
good?
Yeah.
Okay. Again, should be fairly easy, right? We've done all the sub skills. It's just like taking the same stuff we've been doing and like shuffling it around and doing something different with it.